Hey everyone, welcome back to another 3D Desmos graphing series. Uh, in this video, I'm going to show you how to implement multivariable functions into our actual 3D program or a 3D graph. Uh, so I wrote a function here that takes in uh, three uh, 3 points and 3 angles, and it's going to convert them into 2D form. We be sure to output that. Okay, not important. The important part is actually getting this into the graph. So I'll actually be referencing this back and forth as I write these. So bear with me on that aspect. But our function will only need three points or three variables, x, y, and z. Uh, X rotation, y rotation, and z rotation. That's going to be is going to be a global reference. All right. So let's get into it. Okay, so right now I'm on an empty graph right now. Only for demonstration purposes, I will show you what the final product should look like. I didn't show you. No, I didn't show you. Wait. So we need a point. So let's do equals to 2, 2, and 1. And then we're gonna need rotation x, rotation y, and rotation z. I will warn you one thing about this function. It assumes that we are rotating these points about the origin, which will become a problem when you drag. So on your actual graph, when you drag these numbers around, it will become a problem because you're changing the x and y values, and your cube will still rotate around the origin. So if a rotation looks funny, that's probably why. So let's get started with our first multivariable function. I'm going to call this one x1. It's going to take in an x value and a y value. So this is for z rotation here. It's going to need an x and a y. And what's going to be, we're going to copy what we have here. So x times cosine rotation and minus y times sine. Let's be x cosine z rotation minus y sine. Then we'll do something, not the same thing, but similar. For the y, that's going to be y times cosine z rotation minus x, no, plus x times sine of uh, of the z rotation. So let's see how this thing's going to work. So let's make a point at x1. So if we move this 45 degrees, this one, so what actually happened here? There's nothing wrong with what we did. Give me a minute, I'll go figure this out. Okay, so apart from the fact that I changed this value here, I did not touch anything else. It rotated under 80 degrees. Is like it was supposed to around this origin. So that just means that we can keep going. So now let's do the y rotation here. So keep in mind this x value actually got updated from this x value here. So we need to use the new x value, and we can use the past z value for now. So let's do, we'll call it x2. It's going to take an x and it's going to take in an x and a z, because that's what this line cares about. So let's do x times cosine of y rotation minus, guessing it's sine of the y rotation, which it is. Okay, this means z function is x times z times cosine Okay, so this should also be able to now rotate along the y-axis. So let's do, I want to finish this one first. So let's do, I made a mistake here. This is actually, should be x. We already need this extra y parameter here, because this x will, it's actually x1 at xy, and this is actually same thing, x1 xy. So we're using xyz here, xyz here. Okay, so next one we need to update the y. So we need a y2, so and that's going to need, giving it all three parameters just in case we actually do need all of it. So we need to update a y. So we need y1 xy, making sure I'm not forgetting anything. Cosine of theta x, and x minus z times y and z. That was x and z. Confuse myself here. We're over here. This is going to be z times sine of x rotation. Yep. And then this next line is going to be something similar. So it's going to be z to x, y, and z is equal to v1 x, y, z times cosine of x rotation plus y times sine. So I did forget to explain that all we're doing here is we're just procedurally converting x, y, and z into 2D coordinates. So our final coordinate system will actually be a x and z. Well, not x and z, x and y. Y 2 times sine rotation x. Okay, so let's put this to a test. So we're going to need. I feel like I should have done the z first, because what that means now is what we've done is I believe we've just trashed this equation. So this is really x2 this is y2. So let's see this. So z is the easiest case. So that's actually rotates around like that. Y should just only look like it's going horizontally. Yep, doing that. Put it back there. And x should look like it's going vertically. Okay. So let's actually try this on an actual square. So I want to make this bigger. I want to make this maybe let's go 4 by 4. So let's make a table. I'll bring that back. Don't worry about that. So if we want to do one square, we actually need 5 points for the line to go back to the beginning. So let me edit this. So this we want lines on. This would be x2 was that 0, 0 now. Just add the width and height. So we x2 a plus the width. Okay, there's a square. And the easiest case, the rotation should rotate this along. Yep, it's doing exactly what it's supposed to do. Can it do some conjunction to the y? Looks like it is. And we'll just rotate along the x-axis. It looks like it is. All right. So now I'm going to show you how to implement this. And what this would look like if implemented, it will look like this. right? So right now the way I have my graph, it actually takes account into x and y transformations. But if we don't change these values, it should look exactly the same. So y rotation rotates along the y-axis, and z rotation does that, and x rotation should do just that. All right, so yeah, and yes, we did convert these to radius, I believe. If you haven't, I'll leave this up here for you for a moment so you can pause it. If you want the code that came along with the previous graph, so not this version, so this code doesn't actually work for the graph that I just showed you, but this will work if you're only doing the origin. So I will show you next time when we do the origin, or do a point that's not the origin. Okay, so I hope you actually got something out of this video. Sorry about last time; it was actually very theoretical. I didn't. If you need me to explain more, do let me know. I have to have a sufficient number of comments for me to do that again because, as I know, for a for a broader audience, it's actually pretty boring for them because I know you'd rather get graphing. So if you want more explaining, do let me know in the comments. And I will see you in the next video.